Thank you, Charit. Hope I am well audible for you guys.
Yeah, you're audible.
Okay. Uh, Thanks a lot for the lovely introduction and good evening, all. I know it's 7 p.m. in Sri Lanka. It's not a nice time to learn something new. By the way, I'll try my best to make it as interesting as I can. Uh, as Charit mentioned, today the world is all about AI and machine learning, and everything is becoming AI. And you might heard AI every day with new products. So that is the main reason why I accept this talk also. I want my future students, of course, and my next, uh, I would say Nangi and Malli, to learn about these technologies because we have exposed a lot about these new technologies and you guys are entering into the industry maybe next 2 or 3 years. So better if you guys have fully listen and get the exposure out of it. And let's see how we can achieve by the end of this session. So I'll share this screen and let me know if you can see it also. Okay. Hope you guys can see my screen.
Yeah, we can see your
Otherwise,
screen.
let me. Okay, perfect. So the topic of the day is from theory to production, a practical journey into industrial AI and ML. So as I mentioned, this session would be very beneficial if you guys are planning to move to the ML or AI industry as a data scientist, or maybe ML engineer, or maybe a data analyst, or maybe a data science engineer. There are a lot of roles that you can apply after if you're planning to pursue a career in ML and data science. So uh, let me see. Okay. So I'll start with introducing myself. So as Charit mentioned, I'm Sahan Dissanayaka. Right now, I'm working as a data scientist at ISA. It's part of AI Arabia Group. If you don't know about AI Arabia, please go and search on Google called AI Arabia. So it's a low-cost airline. So we actually flying for many destinations, including Sri Lanka. It's a Middle East-based company based in UAE. Uh, I hope you guys know about Dubai, so it's based on Dubai. And we fly to Africa and Asia and Europe. So, and we are part of Emirates. Hope you guys heard about Emirates. So we are a partner airline. And before coming to Air Arabia, so I was studying at the UCSC as a computer science undergraduate, and I was able to do the special degree, a CS major, honors degree, and I was a former Gold Microsoft Learn student ambassador also. And also I did some research work in time series, anomaly detection, and ML ops also. So if you have any questions about time series, ML ops, data science, machine learning, anything, AI, of course, so feel free to drop me an email. I prefer because I have some time and I prefer to mentor some students. So if you really like, if you like to do research with me, so feel free to contact me in LinkedIn also. Here you can see my LinkedIn handle and Twitter also. I'm available. So please reach out to me. I'm happy to help for you guys. And about this session, so first I'll like take you through the industrial perspective of AI and ML. So hope you guys know about ML right now. So now a lot of students are like to do AI and ML instead of software engineering or like electronics. I know you guys coming from electronics background, so AI and ML are kind of the hype, and industry is actively seeking students who can do AI and ML. So it's a very interesting field and a very demanding field. So the things that you learn in the classroom actually not what we are doing right now in the industry. So there is a there is a breach between the academia and the industry. So I'm trying to bridge that gap in the first chapter. And then I'll tell you guys the main challenge that we have right now in the industry as well. So this is one of the good things and very rare things that you can learn from a person, because you have to like have a very good conversation with industry person to know about every aspect about this technical depth. So it's a very important matter right now in the industry. So many companies are struggling to overcome this technical depth. So I'll uh, quickly and comprehensively explain you guys what is technical debt and what is important for you guys to know about these things. And then after, I'll show you guys how to build an end-to-end ML system. So here I mentioned as an ML, so it is actually part of an AI system. So it would be AI/ML system. And at the end, let's take a quick break after the third chapter, like 5 minutes, and let's do a quick demo. And this is the most important part. So this is not a normal lecture that you guys are listening every day in the lecture room. So this is somewhat a uh, technical session. So feel free to engage with me and share that you know. Let's say if you know something additional to the things that I'm sharing right now, feel free to share in the chat also. And uh, like frequently, I will check the chat box. So if you have any questions, I'll try to answer them as quick as I can. So please be engaged. So ask questions and answer in the chat. So it will be not boring if you guys can engage. So yeah, let's start. So let me check the time right now. So it's 7:14. So yeah, let's see. I'll try to make it not a 2 hour session, like 1.5 hours. So uh, maybe 1 and 45 minutes. So maybe we can utilize 15 minutes for the Q&A or whatever the other questions that you have uh, with you, like about industry or how to start a career and what you have to do and how you guys can prepare right now, and whatever the questions that you guys have about data science. As long as it's data science, I can answer. Otherwise, I can't. So yeah, that's the plan. So okay, I'll start from why this talk again. So in a very like procedural manner. So this is not the first time I'm doing a session for the university guys. So I have done many sessions. So frequently students ask like, I know ML, I know AI, I know all the AI algorithms, and what's next? So how can I practically apply these algorithmic knowledge? And maybe you guys do robotics, and maybe you guys do Arduino or whatever the IoT or whatever the things, and you guys know how to build a robot and what's next. So how I can make this a career? So do we have jobs? And will AI take over our jobs? So those are the frequent questions I'm getting from students. So yep. So this is one of the main concerns why I'm doing this session for you guys and to make this a clarity. So, and I will explain the breach and what you guys want to know from like beyond the theory before you are stepping into the industry. And mainly academic AI ML that you guys are learning in the classroom, it's not actually the industry. So it's a total different, not total different, but there are some gaps. So we have to fill it out. And there is a mindset shift also that you have to uh, make your brain a little bit change, like fine tune a bit and calibrate. Because many students think we have to build the accurate and the best model for the industry in order to like advance the AI or something like that. So it's not like that in the industry. So there are like other things comes to the picture, like the business value, like the system. It's not about the model that you implement. So you have to uh, think about the latency, the response time, how we can integrate that model to the system, and is there a wide community. So is there any support, how we can do the maintenance and the support and everything we have to think about when we giving a solution to the industry. So for that, so as an industry professional, so I would say before you are stepping into the industry, better if you know about these things like the technical depth of AI and ML, end-to-end understanding of a data science pipeline or a machine learning pipeline, not just the data, building the model. You have to have the capability of deploying it also in the cloud. So cloud is very, I would say, one of the necessary skills that you need because otherwise it would be bit tough because the understanding because as a student try to like utilize as much as the knowledge you can when you are in the university. So end-to-end understanding is what I meant by there. So, and also the achieving the business goals, like let's say when somebody give you a job, it means that you have to do something good for the company. So it not just implement the best model, like at the same time, it has to achieve the business goals with messy data. So there are a lot of challenges uh, right now in the industry. So the system thinking, the ownership, beyond the notebook, I mean like the coding skills. So this is what we actually need uh, for the industry. So yeah, this is I usually use memes. So uh, b- I just want to make it engaging and make it very understandable. I think meme is a very good way to give the message. So you see, like the Hello World tutorial is not the real world production code. So there is a long way to go. So this is just to understand where you are, not to uh, like uh, uh, underestimating you. Like I know there are many students that are already pass out, like getting very, I mean, get new knowledge very fast. And this is not about all of you. Like there might be students that are think like the things that you do in the classroom would be enough for the industry. So this is not the way. So there are a lot other things. So that's the message I want to give you. Yeah. So you know nothing. Yeah, this is a joke, so don't worry about it. Okay, so I'll start with the chapter one. So beforehand, if you have any questions, please feel free to drop in the chat before moving to the first part. Any questions? Seems no. Okay. Uh, okay. So understanding the AI and ML. So what is actually artificial intelligence? Can somebody give me like a very short answer? What is artificial intelligence? Why actually artificial intelligence got this much of attention of the human being? Anybody? No? Uh, if you are okay, you can unmute your mic or maybe you can use the chat. Either way is fine. So, so shall I assume none of you guys know about AI? Come on, do some Google search and tell me. Okay, so I'll give the answer. So it's like, okay, finally we are getting some answers. Nice, thanks. So, okay, so uh, I see some answers. Engineers to teach machines how to think and act as human. Yes, still valid. Uh, mhm. AI refers to the ability of computer systems to perform tasks that typically require human intelligence, such as learning, problem solving, and decision making. Yes, kind of. So technology that's used to think like human and mimic their action. Okay. Yeah, I think all of the answers covers the main aspect. It because we try to simulate the human intelligence by a machine. For an example, you know self-driving cars, right? Right now in Sri Lanka, BYD is a very popular topic. So because not BYD, actually Tesla, sorry. So it's a self-driving car, and actually you don't need to like give your full attention to the car because car itself can manage the environment and take you to the final destination. So it's kind of like mimicking the human intelligence, right? So let's say when human drives, we see what are the things around, the traffic lights, the pedestrian crossing, and the other vehicles, how we should uh, drive the vehicle throughout the other vehicles. So what happens is that self-driving car, so it takes the pictures from the cameras, and they have the sensors, so they can get the distances. So you guys know, you guys from the electronic background, so you know that it's a sensor system. So we can actually make decisions out of it. So what's come the AI? So we use some models to train the models with that conditions, and we deploy that model to the car, and then it will take the decisions. So that's how we simulate the human intelligence by a machine. So that's just a simple answer. So actually, what's the root? In order to do the artificial intelligence, what we actually need. So what's the root? So what I'm trying to say is like, in order to do artificial intelligence, what we actually need. Yes, of course, we need data. So that's obvious, no? It's like without data, we can't do anything because the observation, we had to train the model with the observations and the data that we have right now to simulate the human intelligence. So the main aspect or the main requirement to do AI is the data. Otherwise, yeah, it's going to be very hard. Uh, there are some learning techniques like reinforcement learning, whether you don't need data upfront, but still you have to train your model in an environment to get the data and learn your model. So still we need data. But yeah. Okay. So I'll start with AI, the AI types actually. So this is one of the philosophical way of introducing the AI. So right now, there are three types of AI. One is artificial narrow intelligence, another one is artificial general intelligence, and the other one is the artificial super intelligence. Artificial narrow intelligence is like a machine or a software or whatever the models that we are building in order to do the AI and ML is specializing in one area and solves one problem. For an example, Alexa, Siri, Cortana, those are like the personal assistants. So when you say something to Alexa, so it will do it, right? So you give the instruction and it does the job. So but if I say to Alexa to run, it can't, right? So it can do only one job. I mean, in a specialized job. So, however, when you move from ANI to AGI, it's a different story. So it doesn't mean that the robot or the intelligence, the object that has intelligence can do multiple things at the same time. The best example is a humanoid robot. So let's say you have a AI helper, so which can clean your bedroom. At the same time, it can let's say do something else. So that it can do some multiple tasks. So, but it at the same time, it has to be smarter than human. So that is artificial general intelligence. And the super intelligence is it's beyond the human intelligence. So the intellectual power of that AI model is beyond human. That is actually we heading right now towards AGI and ASI. Can you guess where are we right now in terms of these three types of artificial intelligence? Are we in ANI or AGI or SI? Or in between ANI and AGI? Mm, it's a simple question, right? Okay. So actually, we are in between ANI and AGI. It's a matter of time. So right now we have all the theoretical perspective or the theoretical background that we need to implement AGI, but still we don't have the right set of data and utilization of that data, and that's the concern. So, but still we are in ANI because still we don't have any uh, like a clear example to give you as an example for AGI. Because if you know the vision models, like if you are into like computer vision, like hope you guys know about ImageNet and Inception and Transformers are not actually not good at computer vision. There are specialized models for computer vision. So actually, it's much better than human in identifying human like the animals. There are very rare animals that it's very, let's say, there is a very popular research done by Stanford University. There were like 50 human versus this vision model. But actually, the AI model surpass all of those human capability of identifying the animals. So the capability of the vision is actually much better than human right now for the AI and AML models. So that's the story and that's the status right now around the world and the status of the AI. And yep, it's very interesting. So we are slowly going towards AGI. So maybe in next 5 to 10 years, we might experience the AGI capability of AI. So how AI evolves? So the theories and the concepts of AI are not new. They are the way back to 1950s. And when people thought about algorithms. So, but the thing was like the compute resources were not up to that level in 1950s. So we were have to like wait until 1980s, 1990s to actually uh, use these AI ML models to implement real world solutions. So in 1980s, the machine learning comes as come to the picture like the email spams. So that is one of the best examples and popular examples for machine learning. And actively, if you still using Gmail or whatever the other uh, emails, uh, you will actually using spam uh, email spam models. So that's how it classify the your emails into different buckets. And in 2010, like very recently, so deep learning come to the picture with the godfathers of AI. So from actually uh, the Lacan and the godfathers of AI, if you remember. Uh, yeah. So deep learning come to the picture with having a lot of good compute resources. We can train deep learning models with very huge amount, massive amount of data. And now, actually, in 2020s, we are right now using LLMs like ChatGPT, DeepSeek, and we are into AI agents. So slowly the software as systems slowly evolving into AI agents. And maybe in future, in not near future, maybe in 20, 30 years, we might see some AI robots, very advanced AI robots that has a lot of capabilities, not just vision, like the we actually, if you really think about the capabilities of AI, now just limited to cognitive space. If you really think like the cognitive abilities means like the vision, the hearing, and yeah, kind of those senses. But when it comes to other things like the running, jumping, so the robots are not actually better than humans, if you think, if you agree with me. So yeah, those capabilities are still a open question, and still we have a lot to do. So that's why I think it's a very good opportunity for you guys to implement that sort of things for the humankind. So yeah, and let me see. Okay, I'll see about agentic AI systems. So that is one of the popular discussions right now happening in the industry, agentic AI. So I'll see. Right now, my plan is to do end-to-end system, but of course, I'll give the difference between a normal ML system and an agentic AI system. We'll see, of course. And yep, uh, since a lot of people think AI and data science is the same thing, uh, I just want to differentiate the difference between data science and artificial intelligence. So, artificial intelligence is the large subset of the whole thing, and then machine learning is subset of it, because artificial intelligence is the whole intelligence landscape, but machine learning is just a subset because it based on the data to make the predictions. Okay, so but deep learning is the main difference between machine learning and deep learning. Machine learning is need an extensive way of doing the feature extraction, but for the or whatever, there is another way of saying this, the handcrafted features. Like you have to create your own features in order to build a machine learning model. But for deep learning, you don't need handcrafted features. Deep learning model itself will create the features and solve the problem. So that's the main difference between machine learning and deep learning. But when it comes to data science, it's just a subset and a merge between AI and deep learning and machine learning. So we use statistics and business domain as well as the mathematics, of course, machine learning and deep learning to give real world solutions. So that is the main, I would say, in terms of the value delivery. This is the most effective way of using machine learning and deep learning. So that is why a lot of people uh, tends to use data science instead of using AI in their businesses. So make sure to get the clear idea of it. So AI is not data science. Data science is something else. So yeah. Okay. So right now we know and we get some idea about artificial intelligence, machine learning, and data science. So we need, so the main uh, purpose of this session to like bridge the gap between academia and business. So there are a lot of interesting things happening, but is this necessarily impact to the business? So that is the main question that we want to ask. So everything that you are doing right now in your university, will it impactful and will it meaningful for the industry? So that's why I mentioned here how the definition maps with the business application. So whatever the solutions, whatever the AI, whatever the ML, whatever the data science should meet and help for these main three courses. First, to draw the causal insights, predict the future events, and also the understand patterns in the data. Let's take an example and let's get some understanding about it. So, as you know, in Arabia, so we do some aviation-based data science. One of the models are delay prediction. So let's say how that delay prediction models help to the business. So that model should draw causal insights. It means business needs to know what are the causing factors, what are the driving factors that affect to get the flight delayed. So, and also business needs to know, okay, now I know what are the main reasons uh, affected to getting the flight delayed, but I want to predict the future events also. What will happen to the future flights? So how can I mitigate and control and do the damage controlling for the future flights? So it needs to have the capability to predict the future events also. Which flights are likely to do the delays? So if we can predict that, business can take necessary actions to mitigate that, or maybe like take some actions from their side to control it. So the third point, the understand the patterns in data. So this is somewhat strategic. Like let's say every day we are experiencing delays in Colombo to Dubai flight or something like that. So are these group of flights look similar and get delay in a similar way? So let's say from like for an example, let's say from Dubai to Sri Lanka, there is a flight. From Dubai to let's say Mumbai, there is another flight. So the patterns from those two routes are very similar. So let's say we somehow able to solve the problem of getting delayed of flights from Colombo to let's say Dubai. So we can apply the same solution to the other routes as well. So that is how we can actually give the value to the business to mitigate those kind of real world problems using data science, ML, and AI. So yeah, this is the main understanding you should able to have as a data scientist, or if you're planning to have a career. This is the main way of tackling problems and giving solution to the industry. And let's say we get a new solution, let's say new problem. So we need to ask three questions for the business. Let's say they want to do something new with the AI model. Let's say they want to use an agentic AI system for their business. So as the AI professional, you should be able to ask these three questions. Otherwise, you don't use AI, because there is a concept called the essence of AI, because there are many things that we actually don't need AI. With human intelligence or whatever the other things, we can actually implement a very simple solution, because AI come with a cost, because AI is not the whatever the silver bullet for all the problems. So this is one of the other things that students think we can apply AI to everywhere. So I know many students, when they are doing their final year projects, they just put AI without knowing anything. So don't do that, because AI is a technique that we can simplify our day-to-day tasks. It's not a silver bullet, because we can't apply everything. We can't use AI for every. So that's why we need to think about these aspects as well. So what are the three questions that we have to ask from the business or whatever solution for the research as well? This is samely applicable for the research as well. So when you do a research, do this analysis. So the first question is, what is the business situation? Or let's think about the research aspect. What is the research situation? What is the current situation? So, and the next question is, what will research slash business get the opportunity by adding this AI or ML or data science? And what are the actions that we can take at last? So let's take an example and get a good understanding about it. So let's say uh, the business or the airline want to do something very interesting. Like let's say uh, let's say in this meeting we have 56 students, including myself. So we are 56 individuals. Like we are coming from different backgrounds. We have different financial backgrounds, and we have different spending behaviors, or we say like the consuming behaviors, consume aspects. So some people like to purchase tickets for lower prices, and some people like to spend, I don't think so, but let's say expensive tickets. So the consumer behaviors are different, right? So for an example, let's say when you guys are, let's say, something that we usually buy. Mm, let's say food. So let's say some people like to have something expensive per week, like from, like, let's say uh, from a from a mall or some kind of nice restaurant. So the consumer behaviors are different, right? So we let's say the data science team or maybe the airline wants to understand those patterns. So the company plans to automate the ticket prices based on the user. So we call it as personalization. That is the exact things happening in your ChatGPT prompt as well. So actually it understand your prompts, the things that you ask. Just go to ChatGPT and ask this question. I think this is one of the popular things. I think you might already know. So, let's say I will not do it. I will not run it, but because it will roast me. But just type and see. It actually depends on the prompt, all the prompts that you make with the AI chatbot, with the ChatGPT, and it actually summarizes it everything about yourself. We call it as the adapters. There are the concept called adapters. The ChatGPT model built on top of adapters, so it varies the response. Everything depends on your behaviors and depends on your needs. So there are some adapters. So and also there are some personalizations happening inside the model. So those things are happening. So that's how the data science and the concepts come to the picture. So that is what we have to do. Okay. Right now, the situation is we don't have that sort of RAM model. So what's the opportunity by adding that sort of RAM model? So we can reduce the human errors. So the
ඉතින් මේ
sorry.
හැන්තු එක ගෑවෙන්න එපා මහත්තයෝ. ඒක මේ ගෑවුන ගමන් ඉවරයි නෙමෙයි.
So it will reduce the human errors because the ticket person, the person who sells the ticket or maybe the website doesn't know about you, right? So we need to detect your consumer behaviors, the price sensitivities, your personalization, your preferences, everything we need to know from the pricing engine. So via adding that, we can actually enable to fluctuate the prices and invest more. Maybe they can get more revenue out of it. Let's say uh, you are willing to pay more, but actually the prices are pretty low and the business can't take the maximum out of you guys, right? So that is the business opportunity we call. So we can do it via artificial intelligence or machine learning. Okay, hope you guys know, I think get the essence out of it. So how the AI and ML and data science meet the business. So it's not just the theory, it actually has to be very practical. So you have to think about a lot of things like how before you are going to give a solution. So think about it. And I know you guys are still studying at your university, but as I said already, one day you will step into the industry and you will work as professionals as me. So in few years. So think about those things. So the industry is actually driven by the values, not just the technology. They doesn't need the best model in the world. So they just need the model that gives the better solution. Okay. So the common business application, I think you might already know. So there are three kind of solutions right now heavily used by the industry. One is supervised learning, this classification regression. And one of the examples that I can give you for the classification, we need to know the customers will enroll into the loyalty program. So these kind of like classification problems, whether you are going to enroll the loyalty program or not, in how many days you will enroll. So it's a matter of regression problem also. In unsupervised learning, we need to like do clustering, segmentation, the flight behaviors. So recommendations, we need to recommend you new flights, anomaly detection. So we need to see uh, the cells anomaly detection. So there are a lot of applications that we can think of. And reinforcement learning also, the Q learning, LLMs. So there are many applications and a lot of solutions right now actively using by the industry. But the thing is, the approach. So we can't just run a notebook in the production. So you can't just write whatever the code in a notebook and give the solution to the industry. There is a systematic way of doing that. So I think we already tackle the problem definition and requirement in the earlier side. But before that, we have to do some exploratory data analysis and we have to clearly understand the data and then come to the design part. And we call this phase as a design phase. This is the most crucial and most important. That's why data scientists and the engineers, ML engineers, spend a lot of time tackling these problems and what like deciding what would be the best solution to the business. And then it's the sake of developing it. Actually, it's a very, I mean, the most easiest step in the whole pipeline. So developing means like getting the right features and doing the experimental design and do the model training and evaluation. And the developing deployment aspect, again, it's very challenging. So I would say not challenging. Uh, uh, in uh, in most of the cases, people don't actually know how to properly deploy it in a very, I would say, the most efficient and the most suitable way. There are many deployment solutions like you can deploy in the cloud, or maybe you can deploy in a ready-made solution, or maybe you can deploy it in your own server. So there are multiple options. So the setup or the right pipeline for you is hard. So it's again involves a lot of expertise and the knowledge and the hands-on things. So the setup CI/CD, the deploying monitoring is very crucial. So let's I'll like tell you guys why it's so crucial and what are the things that you guys need to know about these three stages. So actually we call it as ML ops. So where the machine learning and data science merge with the ops operations. So as we already discussed about the design phase, the business requirement and the solution that we need to deliver, and deciding which model gives the better solution and which architecture would be better for these kind of problems. And then we come to development. Development means we usually use Python and we do whatever the chip chop and do the feature engineering and setting the right features and using that model and give the model object. So that's the development phase. So after we get that model, we have to make it readily available for the users, right? We have to make it like available and deploy it somewhere to consume it. So that is the deployment part. So if you see, after we deploy the model, we see some model performances. So most of the cases we predict actually like let's say we predict superbly for many cases, but for some cases the model is not performing really well. So again, we have to come to the design phase and see what's going on and what are the things that we can do to improve this model. So again, we have to come to the design phase, and then again we have to do the development, and then we have to deploy it again. So it's a never-ending cycle, I would say, and it's interconnected. So that's why I mentioned actually there are three core stages. Uh, the the interesting fact is these are interconnected. and rely on each other. The design phase actually rely on development and also deployment. And development actually affect to the deployment, and deployment again affect to the design. So it's a back and forth transition, and we have to do a lot. So yeah, that's the story. Hope you uh, got the idea. And this is how I map it. So the design and the development and deployment and the things that we have to do in each phases. So ML of lifecycle, it's nothing but DevOps plus data science. So if you think like this is one of the things I want to say, especially since you guys are coming from electronics. So I know like you guys get less exposure to the software engineering and computer science kind of aspects. Sometimes you might have some modules. So I would highly recommend you to follow those courses if they are optional courses in maybe your third year or fourth year. If you're right now in third year or fourth year, please follow those courses. Personally, I think in future, in recent years, if you are planning to do like start a career in this field, otherwise you can ignore. Please try to follow these courses. Otherwise, you have tons of online courses out there, and try to follow them because this is not actually your area. I know that. The DevOps part and the implementation part, it's not actually your area, but it's worth to know because it's somewhat important for you guys. Because at the end of the day, what will happen? You have the best model in your hand, but you don't have enough resources to make it to the production and make it usable for the other users or whatever the users that you want to make it available. So those concerns are really, really important. Otherwise, it's useless, no? Like you have a good solution, but you can't make it effective to the community. So that's the main thing and the main problem actually in the industry also. So we call it as the technical depth of AI and ML. Before moving to this part, I would like to know your questions and any clarification that you guys need from these points, like the AI and ML and data science, and how these artificial intelligence, machine learning, and data science meet the business, and how it effective and how we have to use it. Uh, any clarification you need up to this level? Okay. Is it clear actually? Is it overwhelming? Like, hope you guys understand the things that I'm saying. Okay. Yes, it's a very good question. So the ML ops, there are many other things like with the ops, LLM ops, DevSecOps, MLSecOps. So all the things actually base upon that whatever the solution that you have in whatever the area that you are working should able to make it to the production and make it available and make it usable to the users. That's the core. Yes, I would say it's the same core. So for the DevOps means like the software has to be usable and it's in a following this a proper practice for us to do the changes seamlessly. And when it comes to ML ops, it's about giving the ML solution reliably. for the customers. So when it comes to SecOps, the security plus operation, it's the same story for the security. For the LLMs, again, for the make it like it's for the LLMs. So I would say it's the same core. Same core in the sense like integration with the ops, right? Not the other part. Okay, I'll move to the next part. Hope that's all questions that you have right now. And thanks for asking the questions. I really like it. And yeah. So the dealing with the technical depth of AI and ML. So this is one of the main and crucial things you should know. I think it's crucial to know as students before, as I said, before moving to the industry. This is one of the main challenges right now in the industry is the technical depth, I would say. If you go and search in Google, this is one of the papers I found in Google research, the machine learning, the highest interest credit card of technical depth. A lot of people think AI is very easy to apply. We just have to integrate the model and whatever the things that we have to do on top of it and done. It's all that we have to do. It's not like that. There are a lot of other things that we have to think about. So if you know, like majority of AI and ML services, especially startups, never make it to production. So there are ample amount of AI startups right now in the if you go to LinkedIn, and every day I see there are new startups coming up for different solutions. Good, but the thing is it's very hard if we don't follow the right practices and right set of the stack to overcome this the technical debt. It's a very less spoken topic, but yet very valuable. So for like avoid the misconception of industrial ML, because a lot of people think it's just ML. We just have to get the data and do the model and ship it. So it's not like that. So it's not as simple as that. So that's why I thought of like mention this topic, and I heavily uh, invest for this part. So please ask whatever the question that you have. I think it's very crucial for you guys right now. So the technical depth is, as I mentioned here, so it's defined as whenever the software is developed in a partial way. So there can be like produce errors, artifacts that need to be addressed in a stable process or features. In other words, like the result of prioritizing speed delivery of perfect coding. So as you can see in this diagram, so this person is trying to drive a bicycle with square shaped tires. So it's not going to happen, right? The square shaped tires is a metaphor for this technical depth. Even if you have the right solution, if it's not properly designed, it's going to be a problem. So that's why you need to understand what sort of technical depth that you have to deal with your AI and ML solutions, and you have to be very cautious about it. And that's why actually the ML ops comes to the picture to overcome this situation, and that's why many organizations heavily invest on ML ops. So if you see right now about the job postings in many like many career pages of in many high like the well-known shiny tech companies, they are heavily investing in ML ops. So they want to streamline the process of machine learning. So they don't want to deal with this. So they want to clearly approach and clearly design and deploy and maintain their solutions. So that's why it's very crucial and very important and very important. And I'm telling again and again. So please give your attention for these concepts. So many people think, I'll try to give you some misconceptions that many students have. And if you already know this, actually you guys are really better. But if you don't know, that's fine. Try to make it a note. So if you think data scientists only do model development, it's not. So you think like then and Shottaka, when it comes to data, so you do everything, all the models that have in the world, you put on top of the data and you uh, create the model. And this is what's happening in a lot of final year researches of many students. So it's not like that. Data scientists are not meant to be like giving the like using just the model. So it's more than that. So you have to like in industrial perspective, like you have to do it automated and you have to practice proper ML ops like the logging, and you have to properly like do the tracing, and you have to like see what's happening inside the system. So you have to like clear logs and clear modularized code. So you just can't write the entire code in a single Jupyter notebook. So you have to clearly make it modularized. So that's how you give a industrial solution. And there are a lot of challenges with the data. So in industry, don't expect very clean and very like nice data sets. So usually they have a lot of problems and cleaning. We have to do a lot of cleaning, and you have to deal with imbalancing, and the sometimes the some columns are missing, so you have to collect it again. And sometimes you have to find other ways of collecting those data. Sometimes, for an example, for the delay prediction model, uh, like many systems are not following the weather predictions, right? The weather condition of it. So it's not available. So we have to get it from other third-party APIs, the weather condition. So because uh, uh, usually the weather conditions are not stored by the airline because they have the other tools to collect the weather conditions. So we have to collect those data from other platforms. So that's how you give a more sophisticated solution. So the latency problem, sometimes your model has to perform really quickly, like within few milliseconds. So you have to make it faster at the same time intelligent. So the more data that you have in your data will take more time to get the inference. That's obvious, right? So it has to be efficient at the same time. It has to be sophisticated. So those challenges are out there. So don't think you just have to add a model and give a solution. And again, if you think like we can run the Jupyter notebooks in production, it's not the case. So, and as I mentioned in this picture, you can actually use Jupyter notebooks. So, actually, what we have to do, we have to refactor and modularize and containerize into Python, and with Docker, Kubernetes, there are a lot of other technologies. Don't worry if you don't know about these things, but just get an idea about how these things are happening. Like that's the message that I want to give to you. Like it's not simple as that. So that's the core that you have to take out of it. And then we have to use the Kubernetes for the operationalization, for the orchestration. So yeah. And this is somewhat maybe that you can easily adapt. So I know many of you guys are using pandas for large data processing. What do you think? Pandas is good. So, or are there any other alternatives that we can use for large data sets? Okay. Most probably you guys will use a lot of large data sets in your final year research or whatever the projects that you are guys doing. Like you will collect a lot of massive data sets. So do you think Pandas is the right solution to do the processing? Yes or no? Yep. Very good. Polars is a very good alternative for Pandas. Yes. Any other answers? Because the Polars actually implement in Rust. So it's super fast, so it's hardware optimized. So it's a very good alternative for pandas. Yeah, you guys actually good. You guys know some stuff. Any other answers? Obviously, yes. For the small level datasets, pandas is good. But I'm talking about large processing. For the small amount of data, yes, Apache Spark is another alternative. Yeah. Okay, so yeah, thanks for the answers. So actually, pandas is not good for large data processing, for big data processing. So there are other solutions. Yeah, of course, Dask is another. That's why I mentioned here Dask. So Dask is multi-processing. So if you know about this the processing aspects, so pandas is single-threaded. It's not designed to do multi-processing. So let's say your machine is Core i7. If you run pandas, it will only utilize a one core. So if you want to use the entire CPU of your machine, you have to use either pandas modding. It's designed to run in multiple processors, so it's designed on top of pandas. So it's really good package. It's a really good package, pandas modding. You can go and search about pandas modding, and Dask is really good. And Polars, it's another good alternative. So you can use those packages. So if you see the stats that I mentioned here, the merge, the concat, the apply map, the read functions are the way faster than pandas. So what about inference? So we just talk about the training right now, up to now. So the training part is done. What about inferencing? So inferencing means you have the model, then you get the predictions. So when you get new data, you have to do the predictions with your model, right? So I know a lot of you guys know about Flask. So Flask is a very popular and lightweight solution to do the inferencing. But actually, the Fast API is, I would say, one of the best designs available in the industry to design APIs for the inference purposes. This actually doesn't meant the dumping part. Dump in the sense like the serialization part of the model. So let's say you have a big model and then you have to serialize it to object. So it, there is it's different from here that I want to tell you. So the serialization part, hope you guys know about pickles and the job libs. There are many other solutions that you can use. But still here, actually, with Fast API, you have to use Onyx if you need better performance. Onyx, it's a lightweight, the runnable objects that you can use to easily do the inferencing. Okay, so do you still think data science is interesting? No, actually, it's hard. So because there are a lot involved, and giving solutions is not that easy. It doesn't mean like I don't want to discourage you, honestly, but I just want to give you the right picture, the truth of data science and AI machine learning. Because a lot of people are coming to doing AI without knowing anything about these things. So they will learn in the hard way. So I don't want you to be struggle. So that's why I spend a lot of time explaining these concepts. So better if you start right now about learning these things. Don't spend a lot of time. Don't actually, it doesn't need a lot of time. So it's just a matter of how interested and passionate you are about learning these things. So try to like I'll give you some insights and some guidance in the demonstration part, but make sure that you get the essence. So I want to like get these concepts correctly in your undergraduate period. So it would be way easier to for you guys to do the rest. Okay, so the model and code development is just the first step, as I said before. So it's a lot involved. You have to think a lot, not just selecting the deep learning model, whatever the transformer or the CNNs or autoencoder. There is a lot involved. So that's why I just want to give you that examples. So to take, I mean, in terms of time, even though I mentioned it takes only few weeks to develop and test the locally in notebooks, it depends on how complex sort-time model you are using. Uh, okay, it's a nice question. So, okay, I'll give my view. Actually, I was planning to talk about vibe coding as well. Vibe coding is, I would say, again, vibe coding is good when you know stuff. I mean, when you know the stuff, okay? It's not good for the undergraduates or the junior people that move into the industry. I actually don't recommend, I'm sorry, actually I don't recommend vibe coding because vibe coding is something that you utilize and because you are heavily rely on the tools, right? Yes, it's productive and to use the tools, but I would say learn and then use the vibe coding because for an example, I'll tell you an example because uh, I'm a person who is really not a fan of GPT models, to be honest, like GPT and Ask, and I'm actually not a fan because it drains out your thinking ability. If you really think when you type something with the chat GPT and actually uh, you actually draining yourself, right? Because you are not learning anything. You are just typing and you get the response and you just copy paste the entire code and paste and you do the stuff. But you are not getting the essence. You not get the concepts and what you're trying to solve and how we have to solve things like that. So I would say use vibe coding in this manner. First, do the problem solving by yourself. So let's say you get something, you have to do something. Let's say you have to implement a sorting algorithm. Okay, you have the data, you have to sort it. First, think what we have to do, right? Yes, we have to do sorting, and right now we have sorting algorithms. Yeah, we have like the linear algorithms, and we have like the merge sort, quick sort, like the divide and conquer methods. So there are a lot of algorithms out there. So first, you have to know that knowledge, right? Don't entirely rely on the chat GPT to get the stuff done. So yeah, that is my perspective. So vibe coding is good. It's really productive and it's one of the good concepts. But the thing is, industry people don't actually fans of vibe coding. So first, you have to know the stuff and then you use the right tools to make it productive. So as students, I would say don't follow vibe coding because this is the phase of learning for your life, right? This is you guys are meant to learn. So learn in the hard way, do the errors and understand what's the things that you have done in the wrong manner and then learn. But of course, get the support of the tools, but don't rely on it. Okay, hope you got the answer. Okay, yeah, another good question. So, is open source LLM are ready to use in production? Can we inference open source LLMs? Yeah, of course. Uh, I'll keep it this to the demonstration part because uh, there are uh, many open source LLM models. If you go to Hugging Face, you will see a lot of LLM models are there. And I'm not sure about the response time because I believe the OpenAI and the Mistral and the Gemini and all the the big giants of LLMs. So they meant to create their models inference friendly. They want to like reduce the latency. So I would say it's questionable with the model that you guys are using, but I would say the open source model that I know, like the Llama, the Mistral. So those kind of models are really good at training, but for the inferencing, I'm not sure. So I have to check because I haven't used open source LLMs for inferencing. But we can do optimizations to the fasten the inference time. Yeah. Thanks for the question. I really like it. And yeah. Okay. So yeah, where are we? So we have to pay the hidden technical debt involved in AI and ML. So I would say since you guys mentioned about these LLMs and everything, now this technical debt drastically reduced because that we are using APIs because now a lot of solutions implemented via AI are just API calls, right? You just create the prompt and send it to the API and get the results and get the other things done. So I'm not just talking about LLMs here. So that's the thing. So because LLMs, if you implement LLMs from scratch, the story is really difficult. I mean, really different because you have to optimize it, and because the training an LLM in-house, it's really hard. You guys know, right? Because we need large data sets to train a LLM. So, but for this case, like the OpenAI and Mistral and the Llama and Google Gemini or whatever the other models that you guys are using as LLMs, it's just an API call. So you are using the just the front end of the model. Okay. Yeah. Okay. So for the data science solutions, if you do everything in-house, so you need to think about the packaging, then scale out the tuning and the instrumenting. Instrumenting in the sense like the monitoring, how the data drift is happening, how the prediction shift is happening. That's how you do the automation to retrain your model. So there are a lot of challenges. So if I answer to my question, so this is a very interesting stack. 87% of AI and ML projects never make it to production because they don't think about these aspects. So if you're planning to start a startup, this would be really beneficial because you need to reproduce research and you need to rely on data. You need to share your models and research with your peers and whatever the teammates and iterate on research on quickly, robustly, and keep track of the experiments. So the teams don't, if you don't have as ML teams, you don't have right solution for these cases, it's going to be hard because you can't do the reproducible ML and accountable data flow and store, collaboration, CI/CD, and tracking and experimentation. So that's why a lot of AI and ML projects and the teams and companies not having a great time with the solutions. So which tool or service we have to use? That's the obvious question we get, right? So there is the landscape called MAD. So I'll show you. Just go to Google and search man landscape. So every year they update this. I'm not sure about this year. I think the recent one is 2024. So you will see for the infrastructure, let's say for the compute, you might obviously you need processing power to do whatever the data science or ML. So you have the solutions for the storage, for the data lakes and data warehouses, everything is there. So if you're like lost with deciding the right tool, just go to here and refer this website and see what you need. So they include both enterprise and open source solutions. So for your research studies, I would highly recommend this page So just go here and try to follow the right tool for you guys. Let me show you the things that you guys already know. Okay. For the data framework, so you see, right? Let me see if I can zoom it out a bit. For the data frameworks, so you see, right? Hadoop is there, Spark is there, Apache Flink is another option, Dask, Ray. Ray is implemented on top of Modin, actually. So these are the other solutions that you can use. And for the formats, there are JSON, Parquet, and Iceberg. So these are the compressing formats of data, large data. And the query data flow, you can use Apache Spark, GraphQL. There is another called Airflow. So these solutions are readily available. And orchestration is Airflow that I mentioned, the prefect. This is one of the tools that we are using right now. And the languages, Python, R, Scala, NumPy, Julia, SciPy, and Octave. Octave is very popular among the industry, but in the academia, but we barely use Octave in the industry. For the ML option in AI infrastructure, AI deep learning, you see some of the algorithm providers, PyTorch, Scikit-learn, Keras, XGBoost, Onyx. So that's why I think these are one of the best resources that I had during my undergrad. So I just want to share this with you. So just go there, go and refer this web page and use whatever the right tool for you guys. Okay, and let me go back to the slide deck. Okay, there is another question. Yeah, of course. So I'll answer this question in the demonstration. So the token issue is obviously it's there, and token limitation, and that's there are a lot. If I give you a simple answer, there are many other techniques that you can use. So if the token size is large, maybe you can segment it. So let's say you are putting a PDF, very large file. So you can break it down your prompt into maybe 3 or 4, and you can segment it. So and feed it to the model, and the prompt engineering, the rags, and everything is there. And of course, the research is happening to overcome these kind of limitations. And yeah, that's a simple solution. And in the demonstration, I'll try to show you other things we have to think about when doing the parallel processing and utilizing the resources and everything. Okay. Yeah. So and what we need actually is the experimentation hub, the data flow management, model registries, CI/CD processing, experimental tracking, for in order to achieve these objectives when we do whatever the AI, ML, or data science. So these are one of the some of the popular tools that you can use. Like for the experimentation, Jupyter Hub is there. Jupyter Hub is not same as Jupyter Notebooks. Okay, Jupyter Notebook is just it's just a layout to do the notebooks. But Jupyter Hub is for you guys to collaborate with your teammates. So it's provide the login, and you guys can log in and share the same notebook with your peers. And for the data flow and store in the sense like you can't actually rely on databases for the features. So you need another store for keeping the features. So that's why we need feature stores. And for the models, let's say we have thousands of models, and let's say this week we implement a new model, and next week we're gonna implement another model, and then you have to compare those two kind of models, right? So we need a proper maintenance of models and tracking and experimenting the matrices of your model. So we need some sort of like a platform like MLflow to manage the ML models. And for the automation and continuous serving CI/CD, we need Dask for the processing, Prefect for the workflows, and Fast API for the inferencing, Apache Airflow for the orchestration of data. These tools actually right now we are using in industry. So better if you get some hands-on experience with these kind of tools. I'm not sure I can actually show you everything today. So I'll try to show you, I'll try to map this part. We use this tool, kind of like that. So I'll uh, try to demonstrate the Python code, and this Python code should be involved and should be inside this tool. So that's what I'm planning to do today. So let's see. I'll try to make it like as easy to understand for you guys. So like there are tons of tools that we need in order to properly place uh, the ML of life cycle. So how we connect these dots? So that's why we have we have this concept called end-to-end ML systems. So I would say building end-to-end ML system implementation. So we know like we had a lot of tools like this, Jupyter Hub, Feature Store. This is actually Feast. The icon of this, the box is Feast. How we connect the dots is like this. So first we have the notebooks and we get involved the processing with Dask. And this notebook actually feed into the workflow or the data flow with Prefect. And all those things actually tracking by the ML flow. And then after we uh, done with the workflow, we can get the model and it's just a matter of model serving. So this is the typical workflow of ML end-to-end. So for the platform, actually we use Azure or Oracle or AWS or Google. Platform actually you have to decide. So that's why I didn't mention anything here. Platform is already, it's the cloud. Or maybe if you have a good machine, you can use your own hardware. But I would say the cloud is the best option because we can go with pay as you go. Because if you planning to use your own hardware, it would be much costly and you don't know about the billing and maintenance, so it's kind of like risky. But yeah, of course, so for your research, you have to use your own hardware. If you have some cloud credits, better if you can use those. But if you're planning to do your research in your own laptop or maybe a server, the platform is going to be your machine. So the other way, without tools, if I be more theoretical, so we actually start with data transformation. Whatever the things that we do start from the data. So data flow management is the first step, and then we step to the feature store. After you do the training, you will get some features and you will get a model. Okay, so we store the features in the feature store. We store the models in the model registry, and all the steps actually we track in the experimentation hub, and we use for all those steps the distributed computing, the processing. And then we move to the inferencing part. The feature server is for us to see the features, and we have to see uh, the monitoring of the features. With the time, you have to see, let's say, the flight delay. We want to see the delay of the flight, the one that we predict, and the actual. And we want to see the curves, how the relationship happening. If it deviates from the actual, it means your model not performing really well. So again, you have to retrain. So that's why you need some model monitoring and feature monitoring, feature server, the inferencing. So that's how it happens. So this is kind of like a simplified version of the complexity of this slide. So we start from the collection, extract data from source systems, and store data in reliable storage. So actually, in enterprise version of it is like many ML teams in the industry. So we have dedicated person called database administrators or data engineers to maintain this data. And then data analysts and data scientists come to the picture and they prepare and analyze the data, they clean it and make it usable. And for us to understand the trend, actually, the distribution, the segments, correlations, and everything. So this is one of the most the toughest job out there. Even though we have the data, we have to have the right data for us to make the make it more effective for the ML. And then ML engineers, data scientists, ML ops come to the picture, and then they prototype, they build the models, and they do some testing experiments, and they deploy the model in production with automation. So this is again the fully automated ML service. It should stand out as like this. So again, it has to be pair with the one that I shared in the earlier, the design, development, deployment phases. So the training, this is not, don't like confuse with that 3 cycles and here. That for the entire solution, the design, development, and deployment. This is for development and deployment, okay? Development deployment is actually, we have 3 phases again, the training and then the prediction and then the monitoring. It has to be automated. Like the monitoring pipeline will show you how well your model is performing, how well your features is performing, and then it will decide you to retrain your model again, retrain your data, kind of like that. So, okay. And here, that is one of the pipelines that we are using right now in our ML teams. Like we have the data in the data lake, and we have our own feature engineering pipeline. We call it a feature store. And feature store is the output of the feature engineering pipeline. And then we use feature store to train our all ML models, deep learning, or whatever the agentic AI models that we have. And then we feed the ML models to the ML model registry. We call it ML platform. And then we send the model to inferencing. So it will use for the predictions. So inference pipeline is actually make connections with the monitoring pipeline. You see this connection connected with our storage and then the monitoring. Monitoring will trigger the alerts. Like let's say we have to achieve some sort of like accuracy or precision or recall. If it's not up to that level, so it triggers. So your model is not good, return again, kind of like message. So it will trigger maybe manual or automated, and it will re-trigger from here. So that's how the connection is happening. This is somewhat advanced, but the same concept. This is actually from Google. So that's how Google is doing the ML ops. So if you guys are interested, I'll share the link with you guys. So just go there and learn the things that you like. Let's say if it, I would say, if you think you can get something out of it, so I'll share in here. But I would say it's kind of like difficult. Okay, it's a nice question. So you said LLM building from scratch is very difficult. How you think about 1-bit LLM? How about 2-bit, 4-bit? It depends on number of parameters that you have in the LLMs, right? 1-bit or 2-bit or 4-bit. So I'm not sure the 1-bit you mean about 1 billion parameters or something like that. So usually LLM, the complexity of a LLM model usually measure via the parameter size. So the Mistral 7B model, I think, let me see if I can go to the Hugging Face. Yeah, let me see from here. Okay. Yeah, we have it. So Mistral small means 3.2. Now they have done another new release. So it means 24 billion parameters. So it means it's not small, but still it's kind of small compared to other models. So there is another model called Mistral Small 125. Let's see the parameter size of this. Again, 24 billion parameters. So I'm not sure what you meant by the bits, but I think you meant about the billion parameters. So yes, if you have lesser parameters, the complexity uh, is less. So it would be uh, yeah, should be more easier for you guys to train. But the other thing that you have to keep in mind when you implement, let's say if you're planning to build an LLM from scratch, see what you actually want to achieve from the LLM. So let's say uh, if you can do the same thing from a transformer, it can be much better than the LLM. So because LLM, either you are just using the encoder and the decoder may be the whole thing. So just think about that aspect as well. So yeah, that is one of the advices that I can give to you. Hope I answered to your question. If not, if that not is the right thing that you want to know, just let me know. Okay, so I think we are actually come to the demonstration part. And yep, as I mentioned here, it's a very cute theory. So the components are really nice, the architectures are really nice. So let's actually get hands-on and see how we can do it in for a real world problem. So I would like to take a 5 minutes break. I just want to get a cup of coffee and I'll come back. And yep, at the same time, if you have any questions up to now for the like using the getting the right understanding from academic ML to industrial ML and the technical depth and building end-to-end ML systems. If you have any questions, feel free to drop in the chat. So, uh, okay, I will. I will. That is one of the things that I have planned. So, to give you guys a roadmap for learning the AI, I will give uh, a clear roadmap for you guys by the end of this session. Okay, I'll come in 5 minutes. I think it's now, uh, what's the time? Okay, it's 8:14. So we have 20 minutes for the demonstration. So we'll take maybe like 4 minutes. Let's try to start by 8:45. So we have 15 minutes for the demonstration. Okay. Okay, let me share the screen again. Hope I'm audible and don't think it's, let me know if it's not. So for the next part actually, and I'm planning to do a small demonstration on how we have to tackle a real world ML or data science problem. So about this problem, this is somewhat related to aviation because because I can give you more clarity about how you have to approach and the real world behaviors of when we are tackling a solution like this. So about this data, this is contained like the passenger satisfaction survey. If you know, if you use some products, we usually get some surveys, right? The satisfaction service, the feedback from the customers, and what factors are highly correlated to satisfy passengers, and what are the things that we can do so to predict passenger satisfaction. So I'll now go to the Kaggle link. Let me share the link with you guys. And let's see. Okay. Thanks, Kavindu. So this is the link. Uh, this link should be the same. Yep, the same link. Okay. It has around 22 columns for the data set. So basically you can uh, click on, let's see, yeah, you can click on the download button and click on the data set as a zip. So it will download the zip and then you can compress, or then you can extract. So it should give you guys these two files. One is train.csv and other one is the test.csv. Uh, yeah, try to make it because I can share the code with you guys, either whatever the way that you find it easier. Because with the time, I think it's better you guys can do the demonstration with me, and because you can ask whatever the questions that you have, and and anyway, I will share these notebooks with you guys, and so don't worry about it. So actually, I have three notebooks. One is for the EDA, another one is for the feature extraction, and the other one is for the modeling. Why I create three notebooks? I just want to highlight you what are the common pitfalls and what are the common misconceptions that students has about in these essential three steps of the pipeline. For the EDA, we will purposefully miss some of the crucial insights and what are the things that we can actually incur from the data set. So it's really crucial. And that's why I dedicate an entire notebook for EDA. And for the feature extraction, I just want to let you know how we can create new features and how we can eliminate some of the features, and the explainability is sort of like that. And the modeling, again, I just want to show you how we can make it inference friendly. So yeah, and then I'll try to demonstrate you how we can create an API and make it usable in the real world context. So let's start from the EDA. So as you guys can see, I have this code. I'm using pandas and NumPy and matplotlib seaborn. So if you are planning to use modding, you just have to use modding.pandas. And for this case, again, I will stick with pandas because I don't want to mess with your knowledge, because I know a lot of you guys are know about pandas. But in the slides, I mentioned about new tools like Modin, the Dask, and the Polars and everything. So for you guys to learn, because I don't want to like b- way different the things that you already know. So that's why I use pandas here and NumPy. So and then here I will import the training.csv, and you will see there are 24 columns including the ID. So probably we can ignore this ID. The other columns are the data that we already want to get an understanding about this satisfaction. So just let me know what are the labels and features of this problem. This is one of the things that we already need to understand. What are the features and what are the labels? Or like just let me know whether this problem is a classification or a regression. This should be classification, right? Because we as you guys can see, as per the data set mentioned in their web page. So what factors are highly correlated to the satisfied or dissatisfied of the passengers? So there are two classes out there called satisfied and dissatisfied. So there are clearly we can see two classes. So it's a classification problem. So it's not a regression problem. And actually the labels are the satisfaction, and the features are the other set of columns that we have, namely gender, customer type, age, type of travel, class, flight distance, in-flight flight service, departure, ease of online booking, gate location, food and drink, online boarding, blah, blah, blah. So those will be our features for the problem. So one of the things, as soon as you got a data set, try to use and utilize these functions called the ds-info. This ds-info function actually gives you a better picture of the data, how many null values you have and how many the count, the data types and everything. You can get a clear understanding whether you have to proceed with the data cleaning step or not. So that's why I mentioned include these two functions, ds-info and isNull with a sum. So you see this data set is uh, actually very clean, but the arrival delay in minutes has 310 null values. So we have to eliminate that. So these functions are very simple yet very effective for us to do a proper EDA. So with that, let's do the distribution analysis and make some plots. So you see, I'm using Seaborn. Seaborn is it gives much more better visualizations than Matplotlib. So that's why I'm using Seaborn. Uh, Here I'm trying to understand how many classes out there for me to understand the labels. So this is mainly for me to understand whether they have a class imbalance. Okay. So you see like there is no class imbalance also. So we have like for the dissatisfied, they have like around 50, 58 or something. For the satisfied, 44 something. So still it's valid. So it's not imbalanced. So that's why I mentioned it's not imbalanced. So here, actually, if you see the features, there is a feature called, let me show you, open with Excel. Hmm. Okay, let me install the Rainbow CSV. Okay. So you see, like there is a there's a feature called class. So the class means in which cabin that passenger is flying, whether if it's business or economy plus or just like that. We have usually a lot of airlines have three cabins. There are maybe like exceptions like four cabins, but usually we have three cabins. So like economy plus, business class, and economy, and there are maybe like first class cabins also. So altogether four classes. So you see the class imbalance with you see we have less data for economy plus and more data for economy and business. So this might be a case. So even though your solution is to give customer satisfaction, this model will not work properly for economy plus. So that's the main message that I want to give to you. Even though your solution has enough data, it will not properly behave for some sort of cases. Okay, so that's the main analysis or insight that we can take out of here. So these kind of facts actually we have to spend a lot of time about negotiating the limitations of our solutions, because otherwise they will think this is a very nice solution, and after that they will complain that your model is not working properly for these cases. So it will be adding a bad picture of your expertise or skill set. So that's why we need a proper analysis of features and clearly understand and communicate what will be the limitations of your AI solutions or ML solutions. So for that, you need extensive analysis of your data. So data is not our problem, right? Data is provided by the business or whatever the maybe open data set. So whatever the solutions that we are giving can have limitations. So it's very crucial to understand the limitations. So the service features, so usually these are the services provided by the flight. So this will be the front end of the customer satisfaction, right? The in-flight Wi-Fi. If you travel to other countries, you know those things. Let's say if we have Wi-Fi service inside our flight, it will be it's nice, right? So customers can watch movies or chat with the people, and food and drink and seat comfort, in-flight entertainment. You can watch movies, onboard services, leg room services. So those will be the front-end services of the flight. So we can see will whether there will be a relationship with these services and the satisfaction. So for the in-flight flight Wi-Fi service, you will see uh, most of the people like uh, give, let's say, neutral or dissatisfied people has make it in-flight flight service as 2 or 3. For the satisfied people, it make it as 2, 3, 4, or 5. It means like it kind of like a driving factor for the satisfaction, right? Because a lot of people that make it satisfied make it in-flight flight service as 2 or above. So if there is a clear mapping. Also, for the food and drink, so if they got a good food or drink, like they make it like 2 to 4, like still good, but still we have some dissatisfied customers. So we can see, even though we provide food and drink, customers can be dissatisfied. And still, and seat comfort, you see here, this if the seat comfort is really high, customers are satisfied. If it's not, it's a dissatisfaction. So it's a really driving factor. And for the in-flight entertainments, the same story. Likewise, the onboard services, the same story. Legroom again. So it's 50-50. So let's do some other analysis. So here you see the satisfaction by travel type. So type of travel is the here. So the purpose of travel is personal business. So usually those two will be the main two purpose of travel, whether for tourism or for the business purposes. So usually mostly the dissatisfaction customers are from personal travels. You see, like, so satisfaction of, because business people doesn't bother about the satisfaction because they want to fly for business, or maybe it's a due to travel or something like that. So they have to deal with it. But for the personal travel, it matters, right? That's how they will travel with you again. So that's why we have to like give more, I would say, more focus towards the personal travel. So see, the again we have a limitation of the data set. So we mostly have the business travel. Let's say from the business, we get a requirement like we want to transform many personal travel members to satisfaction roles. So we need more data for that, right? So the correlations you will see, uh, you, you will see like let's say mm, numerical columns. So okay, so between the features of numerical columns, so we can see some highly correlation between in-flight flight service with AS of online booking. So there are some, it's better we have the target column also, but I didn't mention that. So don't worry, we can do a lot of analysis for the moment. Let's go ahead with other things. So arrival delay and the satisfaction. It's one of the driving factors. If you see in the internet, the one of the driving factors of the satisfaction of a customer is the flight not getting delayed. So if we have the delays and dissatisfaction, you see there is a clear difference, right? The dissatisfaction comes with having lot the amount of delay that you have for the flight still, but the satisfaction group also have some outliers, but you will see a clear difference. And age distribution, this is for us to understand the demography of the consumers. So you will see the age group. It's obvious. So you will have the childs and the young group, and then the mid age, and then the old people. Okay. Hope you get an understanding about ADA and what are the crucial insights that we can make. It's really crucial about understanding the data and understand the limitation and the pros of your data sets. And this is one of the thought process and the mindset that you have to make when you move to the industry. Okay, let me set the terminal. So let's move to the feature engineering. So the purpose of this notebook is to create the right features for our model. So the output of this notebook would be the feature store, of course, but I don't have feature store with me because I'm using my personal laptop. So I'll try to show you one of the feature stores, the readily available feature stores and how it behaves, kind of like that. So let's say we have the same training data set. So yeah, okay, we are imported that. So first we have to deal with the missing data. And then if you see, we have to, okay, this is one of the things I just want to highlight here. Mostly we have to deal with either numerical or either categorical. So numerical columns are friendly for ML models, but categorical is not. You have to convert it to numerical. So that's why I mentioned here and I'm decompose my feature set into uh, my categorical features into numerical. You see the neutral and dissatisfied, I label it as 0, satisfied as 1. Okay, so it's a binary classification problem. I would say it's a multi-classification because we want to predict either 0 or 1, but there are two classes, but it's not like it's a clear binary classification, is it? Like there can be lot other in the future. So there can be a middle group like mid satisfaction or something like that. So let's consider it as a multi-classification problem, but for this case, it yeah, it's a multi-classification problem. We only have two classes. Uh, okay, right? So here I'm doing some imputation. Why I'm doing imputation? My training set is not that large, so I have very few data sets. Like yeah, it's few. It's contextual, but still we have some 100,000 data, but still it's a few, right? Comparing the other data sets readily available, so it's a very small data set. Otherwise, I can't do this demonstration with a GB, let's say, data set with a huge amount of data. So we do some imputation for the numerical and categorical for to deal with the missing data, and then we do the pre-processing to create the normalized set of features for us to do the modeling. Hope that's clear. And let's move to the modeling. I know this is the most interesting phase, and yeah, since it's a classification problem, I'm just using uh, only three models. So let me show you. I'm using logistic regression and random forest and XGBoost classification. Okay, so these will be my three models. So I'll use logistic regression as the baseline and random forest and XGBoost as uh, the the models that I'm interested to apply for my case. Let me see. Okay, I don't have XGBoost. Install it. Okay, so let me try it again. Okay, so I have the training CSV here. We have two ways of doing this. So I'm purposefully ignoring the preprocessor. So preprocess version of my features. For the simplicity, I'm using the training data set. Why I want to like show you the inferencing part very quickly. So I will ignore the other parts. So the pre-processing part. And yeah. So here you will see I'm mapping the target column into numerical, and the target is set. And okay. Let me see if I can. For the sake of, let me see if I can print out the columns that I'm using. Numerical calls. Okay, let's see. All right, so uh, do you see an issue of these the columns? This is one of the things that you have to keep in mind when you work with data science. The feature names, do you see any issues? If you're able to tackle it, it's really good. Okay. With the time, I'll try to explain you guys. So you see, like the names, like the flight distance, we don't have the single string, right? Okay. So it like we have to make either underscore and make it a single string. It's okay, but if we are properly following because sometimes you might get errors because of having the gaps between your features. So yeah, that's why. So make it a note, and when you deal with machine learning models, try to make it a single string of your features. Okay. So we have the preprocessor, and now I'm trying to model it. Yeah, these are very simple things. So as I promised you, I will explain how we can map this part with the tools that we have already. So this part actually, the train test split, the pre-processing. Usually we have a feature store solution for save these objects, like for the preprocessor, the pickles. We usually utilize a feature store to keep the features, to streamline the feature process. And for the workflows, for you see the pipelines like this, okay? Like the pipeline, the steps like the imputation, the scaling part, normalization, everything. For that, we are using a tool called Prefect. Okay. I'll make it a note here. We can replace these workflows with Prefect. And also this part actually replace with the feast or feature store. And actually this part, usually we use ML flow kind of a solution. ML flow for tracking and expiry. So I'm only using 1,000 iterations, and for random force it's 100. Let me see the numbers and the validation evaluation of the models. So you see, for the logistic regression, I'm getting features F1 score of 0.89 for the 0 means like dissatisfied customers, and for the 0.06 for the satisfied, still good. But if we move to the random forest, you will see more good results like 0.97, 0.96. For the XGBoost again, 0.96 and 0.97 and 96. But if you see, the random forest and XGBoost still gives the same number of factors. It means like since the data set is small, the models, whether if you're using a more complex or n-assemble kind of like model, it doesn't add many cents for your evaluation. So since it's a very small data set, random forest it's much enough for your modeling. So these kind of decisions you have to do when you do the modeling. It's not just applying the best model right away. So first you have to apply the baseline and then compare the baseline performance with the other models. So that's how a proper data scientist do the modeling and speak the numbers. So here actually I'm using the columns for me to do the inferencing. And here I'm saving the model for me to do the inferencing. Okay. So, okay, and I'm saving my XGBoost model. So you will see my best model is where I'm pretty, yeah, my best model is XGBoost right now. Okay, yep, yep. My best model is XGBoost, and I'm saving it as a pickle file here, like this. And it's a serialized format, so it will not print anything if you click on it. And yeah, so then this is the other part. If you want to make it inference friendly, you can use there is a there's a package called Onyx. So it might need some additional steps like this. So what it does is it converts it to a vectorized format, so it's super fast. And let's say if it takes 50 milliseconds for a one prediction, it can optimize up to 5 to 10 milliseconds. It's 5 times faster than a normal object serialization. So this is one of the popular techniques used in the industry, especially for LLMs and whatever the formats when you save and compress. So that's why I thought of like giving you some highlights about these packages, but for now I will not save this because it needs some additional steps and some uh, unnecessary things that we want to waste if we go with Onyx. But make it a note like in industry we heavily invest on Onyx when we deploy the services and serializing it. Okay, so all good. So I will use my model for me to give the prediction. So let me run this fast API. Why fast API? So if you know, one of the fast API is one of the best RPS served. RPS means request per second API available in the market. So one of the good APIs. I mean, it has a nice community and it has a. Let me install UVCon and explain you the concept. Okay. So let me like show you the API. So you will see in my API, I have a predict endpoint. So it will take the gender, customer type, age, type of travel, class, flight distance, in-flight flight service, departure, arrival, time convenient, ace of online booking, all the features that I need to give the prediction. Okay. But as I mentioned, so in my data set, there is a very clear problem because my data set only have names without underscore, right? So this is a very fundamental problem, and this is one of the lessons I learned during my undergrad. So to make all the features with underscore uh, for the ML kind of solution, because some packages doesn't, the fast API doesn't allow you to define variables like this. Okay, so even though your features are not underscore, you have to follow the validation process because fast API has a very solid way of validating your requests. So you have to follow the common practices when you deal with data. So don't use not underscored columns. Please follow that because now if I use the Postman for you to like demonstrate one of the requests. Okay, let me see. It's happening. I hate these kind of things happening during a demonstration. Okay, anyway, so we got the request. Let me uncomment it. Copy and paste here. JSON. You see my endpoint is in 0 50 50. the post endpoint is predict. So that is the endpoint means the URL that we have to provide in order to get the prediction from the model. So let's send this request. So let's see what's happening. So it should fail because we are using in our, this is what happened during when you have to work with ML ops and data scientists. Data scientists don't follow the proper common concept, like the proper industrial things, the best practices. But when the ML ops person or the ML engineer comes to the picture, they have to deal with a lot of problems because the prediction failed. Because the problem is, I will show you the logs. You see, the models has the values in without underscore, but I'm sending a request with underscore. So I have to do some, what do you call? So here I have to do some renaming. Okay. Let me see if I can use GPT for this. It's easy, no? Otherwise, I have to type the entire thing. For these kind of things, you can use GPT because it's it's just a matter of productiveness of using, like, for the repetitive tasks. If you want to code this, it will take some time. All right, so I got the right code. And let me go to the VS Code and let me I think this should solve the problem. Okay. So let's see. Let me restart the app. We go to the case, second failing. Columns missing, departure, time convenient, onboard service. Let me see how I send that in the Postman. Onboard. You see, it's a very, when not getting the right features, it's It's not loving. So anyway, you got the message, right? So we have to like what we can see like we have to replace it with the right way of doing everything. Otherwise, you will be in big trouble in the industry. So I don't want to waste a lot of time here, but the message is if you want to make a clear system, you have to follow all the steps clearly and straightforwardly without following the best practices. So because the EDA and feature extraction and modeling usually do by the data scientist. If he not following the right practices, the ML engineer, he is in huge trouble. So with that, I want to stop my demonstration. So let me go back to my slide set again. And okay, we share it again. So yeah, as I promised, so what's the roadmap for you guys to learn and get more familiarity and more hands-on experience on this domain? So I would highly recommend to start with mathematics because mathematics is the essence for data science, AI, or machine learning for anything. If you don't have the right mathematical background, vibe coding doesn't help you because for the debugging, you need a huge knowledge and a clear understanding of mathematics. So that's why I am not a fan of vibe coding. Yes, vibe coding will save a lot of your time, but still when you face a problem, it will take a lot of time for you to solve it. So take as much as time you can to learn about the right mathematics. Start from linear algebra, the statistics, the geometry and everything, and start with Python. So after mathematics, I'm sure with advanced mathematics courses, I'm sure you are following those courses during your first and second years. So that will be more than enough. So for the focused ML courses, there is a nice mathematics specialization for data science in Coursera, deeplearning.ai. So I would highly recommend you to follow that. For the Python, you can follow program Z. So not just the Python language, you have to learn about OOP basics as well, the data structures and everything. And then learn about the pandas packages, sorry, the Python packages like NumPy, pandas, matplotlib, seaborn, and EDA. So for that, I highly recommend to use DataCamp. So DataCamp is paid version. That's the problem. So, but I would highly recommend you guys to use that. So I have a subscription. So for me, it's not the case, but you have to, I think, pay $99 per year. Still, it worth, and you can learn a lot, and you can do a lot of things in data science, and you can easily update with the technology as it move forward. And ML fundamentals, learn about supervised and unsupervised learning algorithms. There are tons of courses in deep learning. I would highly recommend you to follow the Andrew Ng's course on ML fundamentals. For the ML algorithms, there are tons of ML algorithms, so you can't cover everything, but get the essence of every algorithm. There are very popular regression and classification algorithms, and then they have a lot of other variants like for KNN and for ensemble modeling, you will see tons of models like XGBoost, AdaBoost, LightGBM, and in XGBoost there are other variants of it. So you can't learn every algorithm, but there are main algorithms that you have to learn. So learn about those main algorithms. And then you can step into the deep learning, learn about deep learning, neural networks, CNNs, RNNs, GANs, transformers. It's not simple as I'm saying right now. It will take some time for you to get the understanding. That's why you have to start from the mathematical basics first. So it can fast track your learning process. So if you start from deep learning first, it will spend you months or maybe years to learn properly about deep learning algorithms. So start and be patient first about mathematics. So if you know the right mathematics, learning deep learning, LLMs, and whatever the other things are really easy. So by the end, advanced AI, like LLMs, variation autoencoders, diffusion models, and you will see a lot of things. I can name you a lot of things. Multi-weave learning and LLMs, Mamba. So there are a lot of models. So if you want to, if you're willing to learn, there are a lot of models out there and a lot of technologies, a lot of papers, research papers out there for you to learn and read. So yeah, it's a lot of interesting things happening right now in the world, but be patient and invest your time in here. I would definitely say invest in this field. It's really worth. It will pay off a lot, maybe in your future. So feel free, as I said, if you need any help, just let me know. I'm really happy to help you guys. So thanks a lot for me to invite for this session. And it's your time if you have any questions. I know it's 7:30, but I'm really sorry because I had a lot of things planned, but because I know with the time it's will be a lot hard for you guys to keep the focus, and I know it's evening, the Saturday evening, your weekend, so it's okay. I think your organizers already recorded this session, so maybe later you can follow that. And yeah, that's all. Open for questions. Organizers, if you have anything to say, this is the right time. So
Yeah. So do we have any questions from any of our participants? Okay, so
yeah,
I think
okay,
there's
that's
no
fine.
more questions
So
anymore. Yeah.
thank you guys and thanks a lot. Be patient and I know it's a lot. So for 2 hours, but I will share this slide deck with the organizers. So you can maybe later you can follow this and get the lessons or the essence or whatever the things you want to take out of my session. Hope you learned something and yeah, have a great weekend. Thank you. Bye.
Excuse
Okay,
me,
so
Aya.
and do you have a question?
Yeah. Aya, when you mentioned the mindset shift from focusing on accuracy to value in industrial AI ML, could you share an example from your work at Arabia where this shift made a real difference in a project?
Of course. Uh, yeah, it's a nice question. So accuracy versus value. So we had a project called I would say that personalization problem. So for different customers, we have to show different prices. So the accuracy of that model is, let's say, when the customers use the web engine, some users use their email to log first to the system and do the prices. Our model because we implement two set of models. One model is when we detect the customers, and the other model is even though we don't know much about the customers, we implement another model. So we call like identified, not identified. The model that has identified users, we have the accuracy around 85 or 90 or something. So it's a very good accuracy. But for the unidentified, so we just get the cookie details. So if you know about cookies, we just get the other information like the flight behaviors. It doesn't perform really well. So uh, we clearly communicate that limitation of that model. So business understood there is a limitation of their system and they are willing to improve their system in order to achieve this kind of data science. So accuracy is not the case. So accuracy, they try to it's something that we can manage. So it's depends on the business as well. They don't need 100% accurate models. So now from business side, they try to move a lot of customers from identified because they make mandatory to log the user into the system, something like that. So that's how accuracy come to the picture. It's not always accuracy. You don't need to provide the best solution out there for the business, I mean, for the industry. You need to provide that something can work, a workable product, and something they can utilize for their day-to-day tasks. So like that. And I can give you another example. Uh, for the forecasting, that forecasting means we predict tomorrow what will be the delay or something like that, the demand or something like that. Tomorrow we expect 100 customers. Day after tomorrow we expect 150 customers. So we can use either ML or DL, like the machine learning or deep learning. Deep learning models are way heavier, and we can use tons of data to train it. But our ML solutions give much more accuracy plus the explainability, because the deep learning models are black boxes, so we can't take much out of it, like what are the business drivers, and we can't see what's happening and what features contributes a lot for the outcome. So that's why even though deep learning solutions give a lot more accurate answers, we are using the ML solutions because it is a lot more explainable for the business, and it's not about accuracy, it's about the value we can deliver. So yeah, I hope those two examples will give you the answer for your question.
Yeah, thank you, Ayya.
Okay. I think there is another question. A lot of people here seem more into statistics, but I personally enjoy coding development. Okay. Let me understood your question first. So yeah, the math part, I know a lot of people that are coming from other backgrounds, not from computer science, like mathematics, statistics. They can still survive in the industry because they know the way of approaching the problems. So even though you don't have a very solid computing background, yes, you can help solving the problems, but I would say I would highly recommend you to learn the coding part. So because when you have the right, uh, let's say when you know everything, so it's easy for you to adapt and squeeze in to the team, right? Because it's very contextual, because it differs from company to company. Some companies, they are okay with having statistical background for data scientists, but some companies are more they are expecting the data scientists to know about computer science, statistics, and math and coding as well. So it's very contextual, but be ready for everything. So this is your time of learning. So try to be hands-on at the same time. Since you guys are from engineering background, so you have the right skill set of mathematics and statistics. So you just have to invest a small time for the coding, right? So I would say hands-on stuff that heavily with math side, it's okay. So try to be an all-rounder. So eventually you will find the right thing for you. Okay. Yeah. How about computer vision job market? I would say compared to the world, it's terrible. It's terrible. So the opportunities are really less. And this is, I think, in near future, there will be a lot more opportunities. But this is one of the other advices that I have for you guys. Be international, because you guys are coming from and you guys are the cream of Sri Lanka. Because that's why you are in a state university studying a good degree program. So and you have something uh, exceptional compared to the other people in the world, or maybe in Sri Lanka. So you are kind of like a subset or standout people. So for this domain, okay. So you have the potential to reach out, not only Sri Lanka, maybe for the other industries as well out of Sri Lanka. So Be open. Don't think about Sri Lankan context as well. So if you have right skill set or the right background and right knowledge and right project with experiences, that's why I told you guys, invest a lot of time uh, during this period. So this is from my experience, okay? After you move to the industry, it's very hard for you to learn new things because you are working from 8 to 5. So after that, you have other commitments and it will be a lot more harder to give focus and learn new things. The university time, when you start do your degree program, so you have a lot of time. I know you have a lot of modules, you have projects, you have assignments. Still, you are a student, right? So you can learn new things and you have friends and you can make focus groups and projects and you can learn new things. So this is, I would say, the time of your golden time of learning new things. So after that, you just have to adapt with the new technologies and it will be like you will have some lesser time compared to your university time. So invest as much as you can to learn new things. Okay, another question. Okay, I think that will be all right. And yeah, I hope you learn a lot of things about industry in terms of data science and machine learning and AI. And hope message was clear about the difference between academia and industry and what the differences and how you can make ready by yourself to this difference. And yeah, now the job market is a bit competitive, so I would highly recommend you guys to be more focused and ask assistance from your seniors and maybe professionals and decide what you really want. And if you're planning to make a career in data science, so I'm happy to help. So uh, just let me know. Yep. Another question, is there any benefit learning computer vision? Because okay, the computer vision is a really interesting area. Still out of Sri Lanka, there are a lot of good opportunities. So, but you have to realize I would say, uh, yes, if you need a specialized area, it's still a demanding field. But I think it's better if you learn about modern AI buzzwords as well with computer vision, like LLMs, not just LLMs, like agentic AI. Actually, my focus not about agentic AI today. I just want to bridge the gap. So maybe later we can do another specialized version of agentic AI because within 2 hours, it's very hard to cover the gap between academic and ML, industry ML, and developing an agentic AI. Because for the agentic AI, we need another set of foundations that requires to implement an AI agent. Because we have to start from prompt engineering and come to the RAGs, and then come to the AI agents. So maybe later we can do another session or something like that. Oh, yep. I think with this demand of the AI in the industry, I would highly recommend you guys to learn about agentic AI and LLMs and how you can utilize LLMs for your research. But don't be a servant of LLMs, okay? Uh, Hope you get my point. So try to make LLM as your servant. So because LLM is a tool that you use for your productivity, but LLM is not the knowledge. I mean, it just there. Use it for your productivity. So you guys are meant to build new LLMs or whatever the new systems like LLMs. So don't be a servant of it. So try to make new algorithms or kind of like that during your undergrad period. And yeah, of course, I think so. Yeah, I hope I answered to your question. Hmm.
Okay, so I think that's all the questions that we have for today. And I would like to thank you once again, Mr. Sahan, for such an engaging and insightful session. Your experience and perspectives have been truly eye-opening for all of us here today. And I'm sure this session provided our participants with an insider look at the current state of AI in the industry, as well as you provided us a very interesting practical demonstration. We are deeply grateful for your time and thank you for sharing your journey with us. And before we conclude, we would like to request our participants to please turn on their cameras along with the virtual background that we have provided for a quick group photo. We'll be taking the group photo shot. So I hope everyone is ready. We'll be taking the group photo in about a minute. Okay, so thank you everyone. And thank you once again, Mr. Sahan, for joining with us tonight for Tech Symphony. And a big thank you to all our participants for staying engaged and interactive throughout the session. So until the next time, stay inspired, stay innovative, and keep exploring. Thank you for joining this session. Good night.